NEC Article 210.52, which addresses dwelling unit receptacle outlets, does not apply to a college dormitory if the dormitory does not meet the definition of a dwelling unit as outlined in Article 100 of the National Electrical Code. The key phrase in the definition of a dwelling unit is the requirement for permanent provisions for cooking. If the dormitory in question lacks a kitchen or any designated cooking area, then it is not classified as a dwelling unit under the NEC definition. Consequently, the specific requirements of Article 210.52 regarding the placement and quantity of receptacle outlets within dwelling units do not apply. This means that for a total renovation of an existing dormitory without cooking facilities, the NEC does not mandate the addition of a minimum number of receptacle outlets based solely on Article 210.52. However, it is important to understand the scope of this determination. While Article 210.52 might not be applicable, other sections of the NEC still govern the electrical installations within the dormitory. For instance, Article 210.3 might impose some requirements. Article 210.8 pertaining to ground fault circuit interrupter protection in specific locations, and Article 210.11, which deals with branch circuits, all could have a bearing on the project. Moreover, consider Article 210.70 concerning lighting outlets, which may have different requirements. Furthermore, it is vital to consult with the local authority having jurisdiction, or OJ, as they may have additional local amendments or interpretations of the NEC that must be followed. The AHA interpretation always takes precedence. The design and installation must comply with all other relevant NEC articles and any local codes or regulations. Consider the intended use of the dormitory rooms. Even if cooking is not permitted, students will still use electrical devices such as lamps, computers, phone chargers, and other appliances. Adequate receptacle outlets must be provided to safely accommodate the anticipated electrical load. The general requirements for electrical safety, such as proper wiring methods, overcurrent protection, and grounding, still apply regardless of whether Article 210.52 is applicable. It's important to ensure that all electrical work is performed by qualified and licensed electricians who are familiar with the NEC and local codes. To be absolutely sure, submit the plans for the dormitory renovation to the local AHA for review and approval. They can provide specific guidance on the applicable code requirements and ensure that the installation meets all safety standards. Think about the future needs of the dormitory. While cooking may not be allowed currently, there might be future plans to add cooking facilities. In that case, it might be prudent to install additional receptacle outlets during the renovation to avoid having to do so later. Here's a summary. Firstly, NEC Article 210.52 does not apply to dormitories without cooking facilities. Secondly, other NEC articles still apply. Thirdly, consult with the local AHA. Fourthly, ensure adequate receptacle outlets for anticipated loads. Fifthly, consider future needs. Ground fault circuit interrupter protection, or GFCI protection, is crucial in areas where electrical equipment is likely to come into contact with water, such as bathrooms, kitchens, and laundry areas. While a dormitory might not have full kitchens in each room, any shared kitchenette or common areas with sinks should have GFCI protection for all receptacle outlets serving the countertop surfaces. The NEC requires GFCI protection for receptacle outlets in these locations to protect occupants from electrical shock hazards. Arc fault circuit interrupter, or RSI protection, is another important safety measure that can help prevent electrical fires. RSIs detect dangerous electrical arcs in branch circuits and automatically shut off the power to prevent a fire from starting. The NEC requires RSI protection for receptacle outlets in many areas of a dwelling unit, including bedrooms, living rooms, and family rooms. While a dormitory room may not be considered a dwelling unit under Article 210.52, it is still a sleeping area and should be considered for RSI protection to enhance fire safety. Surge protection is also important to protect sensitive electronic equipment from damage due to voltage surges. Voltage surges can be caused by lightning strikes, power grid switching, or other electrical disturbances. Surge protective devices, or SPDs, can be installed at the service entrance or at individual receptacle outlets to protect equipment from surges. Dormitory rooms often contain expensive electronic equipment such as computers, televisions, and gaming consoles, making surge protection a wise investment. The type of wiring method used in the dormitory renovation must comply with the NEC. Common wiring methods include non-metallic sheath cable, or NM cable, also known as Romex, and metallic conduit. NM cable is typically used in residential construction, while metallic conduit is often used in commercial construction. The choice of wiring method depends on factors such as the building type, the environment, and local codes. All wiring must be properly installed and protected from physical damage. The ampacity of the conductors used in the branch circuits must be sufficient to carry the anticipated electrical load. The NEC provides tables that specify the ampacity of different conductor sizes based on the insulation type and the ambient temperature. It is important to select conductors with an ampacity that is equal to or greater than the maximum current that the circuit will carry. Overcurrent protection, such as circuit breakers or fuses, must be provided for all branch circuits. The overcurrent protection device must be sized to protect the conductors from overheating and to prevent damage to equipment. The NEC provides tables that specify the maximum overcurrent protection for different conductor sizes. It is important to select overcurrent protection devices that are properly sized for the circuit. Grounding is a critical safety measure that helps to prevent electrical shock hazards. All electrical equipment must be properly grounded to provide a path for fault current to flow back to the source. The grounding system must comply with the NEC requirements. Grounding electrodes, such as ground rods or metal water pipes, must be installed to provide a connection to earth. Bonding is another important safety measure that helps to equalize the voltage potential between different metal parts. All metal parts that are likely to become energized must be bonded together to prevent voltage differences from occurring. Bonding conductors must be sized according to the NEC requirements. The location of receptacle outlets in dormitory rooms should be carefully considered to ensure that they are accessible and convenient to use. Receptacle outlets should be located near beds, desks, and other areas where occupants are likely to use electrical devices. The NEC specifies minimum spacing requirements for receptacle outlets in dwelling units, but these requirements do not apply to dormitories. However, it is still important to provide an adequate number of receptacle outlets to meet the needs of the occupants. The height of receptacle outlets above the floor should also be considered. The NEC does not specify a minimum height for receptacle outlets in dwelling units, but it is common practice to install them at a height of 12 inches to 18 inches above the floor. This height makes them easily accessible and prevents them from being obstructed by furniture. The type of receptacle outlets used in dormitory rooms should be appropriate for the intended use. Standard 15 amp, 125 volts receptacle outlets are suitable for most applications. However, ground fault circuit interrupter receptacle outlets should be used in areas where electrical equipment is likely to come into contact with water. Tamper-resistant receptacle outlets should be used in areas where children are present to prevent them from inserting objects into the receptacle outlets. The use of extension cords should be minimized in dormitory rooms. Extension cords can be a fire hazard if they are overloaded or damaged. If extension cords must be used, they should be heavy-duty and listed by a recognized testing laboratory. They should also be used sparingly and should not be run under carpets or furniture. Power strips can be used to provide multiple receptacle outlets from a single receptacle outlet. Power strips should be listed by a recognized testing laboratory and should have a built-in circuit breaker to protect against overloads. Power strips should not be daisy-chained together, as this can create a fire hazard. The lighting in dormitory rooms should be adequate for the intended use. The NEC specifies minimum lighting levels for different areas of a dwelling unit, but these requirements do not apply to dormitories. However, it is still important to provide adequate lighting for studying, reading, and other activities. Lighting fixtures should be energy efficient and should be properly installed. The electrical panel and the dormitory should be properly labeled to identify the circuits that serve each room. This will make it easier to troubleshoot electrical problems and to turn off the power to specific rooms when necessary. The electrical panel should be accessible and should not be obstructed by furniture or other objects. Regular electrical inspections should be performed to ensure that the electrical system is safe and in good working order. Electrical inspections can help to identify potential hazards and to prevent electrical fires and shocks. The electrical system should be inspected by a qualified and licensed electrician. Any electrical problems that are identified during the inspection should be repaired promptly. Here are some additional considerations for dormitory electrical systems. Firstly, ensure compliance with the Americans with Disabilities Act, or ADA, requirements for accessibility. Secondly, provide adequate ventilation for electrical equipment rooms. Thirdly, install surge protection for sensitive electronic equipment. Fourthly, use energy-efficient lighting and appliances. Fifthly, educate occupants about electrical safety. The ADA requires that electrical receptacle outlets and other electrical equipment be accessible to people with disabilities. This means that receptacle outlets should be located at a height that is reachable from a wheelchair and that they should be operable with one hand. The ADA also requires that accessible routes be provided to electrical equipment rooms. The electrical equipment rooms can generate a lot of heat. Adequate ventilation must be provided to prevent the equipment from overheating. Ventilation can be provided by natural ventilation or by mechanical ventilation. Surge protection is important to protect sensitive electronic equipment from damage due to voltage surges. Voltage surges can be caused by lightning strikes, power grid switching, or other electrical disturbances. Surge protective devices, or SPDs, can be installed at the service entrance or at individual receptacle outlets to protect equipment from surges. Energy-efficient lighting and appliances can help to reduce energy consumption and to save money on utility bills. Energy-efficient lighting fixtures such as LED lighting use less energy than traditional incandescent lighting fixtures. Energy-efficient appliances, such as Energy Star certified appliances, use less energy than standard appliances. Occupants should be educated about electrical safety to prevent electrical accidents. They should be taught how to use electrical equipment safely, how to avoid electrical hazards, and what to do in case of an electrical emergency. They should also be taught how to identify potential electrical problems and how to report them to the appropriate authorities. In summary, while NEC Article 210.52 might not dictate the precise number of receptacle outlets in a dormitory room lacking cooking facilities, a comprehensive approach to electrical safety and functionality is essential. This approach includes adherence to other relevant NEC articles, consultation with the AHA, consideration of future needs, and the implementation of safety measures such as GFCI and FSI protection. Furthermore, providing adequate receptacle outlets, surge protection, and energy-efficient lighting, combined with occupant education, contributes to a safe and comfortable living environment for students.